Next section is about monitoring and auto-scaling in OSMs. The Service Assurance Module Development Group covers many components in OSM. It has been growing lately. It covers the MON component, which was the first one, which gathers metrics from the NFBI, basically. It also evaluates alerts, evaluates thresholds, makes sure that that the VMs and beams are up, and those kind of things that are going to keep evolving in this release to have a more complete use case. Policy Manager is designed around the auto-scaling use case. It's covering now some sort, up to some point, VNF Alarms. We saw that in the first day, yesterday, when covering the architecture, the things that these two elements do. You can see more of the user guide, but basically, MON is gathering metrics from the beams, and potentially also from the VNFs through UU metrics. And Policy Manager is taking care of auto-scaling or alarming whenever a metric threshold is crossed. So these are the two actions that Paul is covering today. We have Prometheus as the main time series database, or the only time series database for all the system. It stores all the metrics from VNFs, from the beams, from the system as well directly, because we have some exporter tools storing metrics of the system in Prometheus as well. We have Grafana, which is becoming default. I mean, whenever you install OSM, you will get a Grafana instance that takes care of all the beam, that reads all the metrics from Prometheus. I say it's becoming default because in Docker Swarm is already by default installed. However, in the Kubernetes installation, since it's new, there is a Grafana, but that belongs to the system specifically, and we need to enable the other Grafana for OSM, and then join them together in a single instance. So that's taking a little bit of time, but it should be ready for a next point release or release 8 in the worst case. So this is dashboarding tools. And then we have an auxiliary, what I would say it will remain as an auxiliary tool, which is the ELK stack. Actually, it's EBK, it's Elastic Bits and Kibana. That it's receiving the logs, and it gives you some extra dashboards for processing, logs processed already by pre-created dashboards. But this is not part of the main stack because of the limited use case we've seen, or most operators that are adopting OSM already have ELK, so you don't need it to be included by default. So these are the metrics that are collected in MON. You have infrastructure type metrics, which are the beam status, the SDN controller status, that are controlled by default whenever you create a beam. Collected by default, sorry. Whenever you create a beam, whenever you create an SDN controller, the status is tracked and stored in Prometheus with these labels, the ID of the instance of the beam. You have then, related to the VNF, you have the VM status, which is collected by default as well, is up or down. And then you have others that are enabled by the descriptor for now. There is a motion for moving this as default as well. So to collect CPU utilization, memory utilization, packet forwarding, and we have metrics. Today, VNF metrics, I mean specific metrics of the image of the VNF can be collected through UU metrics. This is migrating to Prometheus exporters in the next release. And we have more labels there because it needs to identify the network service, what's the VNF, what's the VDU, and now we are adding more labels to the metrics. To enable video metrics collection, you just need to specify the monitoring params. Under VDU, put the NFBI metric you want to collect, which are normalized names. You can see in the manual, in the user guide, and put a name to it, and then enable them globally so that they are available for query. Then auto-scaling can be configured by scaling group descriptors, which refer to a configured VNF monitoring param, and then takes care of, well, provides thresholds so that we can scale in or scale out based on the threshold of the value, sorry, of the metric that you specify here, and what are you scaling? I mean, which VDU and what's the count that you are adding or subtracting from the network service. And there is a new section at the descriptors that is for alarms. Basically, we were using a section that was not being used up to release 5, but both are probably going to be merged into a more simple way of describing this. But for now, we have the alarm section where you can also refer to a VNF monitoring param, and then say, okay, if the value of this param is less than 20 or whatever operation and whatever threshold, then the action is to throw an alarm to a webhook service, to a web service that supports receiving messages and is open in a specific port. So this is more or less how alarms work in OpenStack as well. It's more or less the same. Okay, so we have a new thing that provides certain level of multi-tenancy, because Prometheus by default is not multi-tenant. It does not have support for multi-tenancy, but and so we are evaluating other projects for the evolution of Prometheus, like Cortex. But short-term implementation was to enable a new label that is project ID in all Prometheus metrics. So there is already a beta version of this. So it enables us to have per project dashboards, and you should be able to see now if you enter Grafana at this port here. I mean, at the IP address of the OSM port 3000 dashboards, you will see that there is a dashboard for all the tenants of this OSM implementation. And if I visit my tenant, there are 2 beams, which are the beams that we were already, sorry, this is not the machine. So if I list the beams that I have, 37 and 13, these are the 2 beams, and those are up. So it's constantly monitoring that. You're invited to visit your own tenant and see if you have, maybe you have a network service. You will see it there through, let's see, who still has 13. You already deleted. Well, we are instantiating a new network service now, so you will be able to see it. Okay, so now we're playing with this little bit. Before that, there is a new beta feature as well, which is the dashboarder component, which should take care of automatic creation of dashboards. Whenever OSM is installed, you will have system metrics. So let's see if there's. So if you visit here the admin of OSM, sorry, not the admin, but the system metric. This is very similar to what you are getting from Kubernetes installation, but this is merged into the Grafana of the OSM system. It's just a more simple use case that applies to the Docker Swarm installation. Okay, we are trying to converge both to a single set of dashboards, but this is what you get when you install through Docker Swarm. Then you have when you create a project, you should be able to see the matrix of the project. So the beams, for example, will appear there. And in the future, when you have users, you will have also use the Teams feature to create users and tenants at Grafana, but we're not there yet. We have a package that uses this matrix. So I'm going to show you. I already downloaded them, the NS package and the VNF package. So that now you just need to create add those packages into your system. I already did that. Let's have Hackfest basic metrics and Hackfest basic metrics VNF. And then instantiate your network service. We are using the OSM client now. So we put a name, for example, I will put HF metrics 40. The network service descriptor name is the same for everybody, if you didn't change that. Then your beam, mine is called white.40. Then you need to set the management network to the management network that corresponds to our beam, which is OSM Next, and that's it. Okay, I just created an instance which has certain monitored metrics over there. Let's see. In the model, I'm including at the BDU level 4 metrics to be collected: CPU utilization, average memory utilization, packets received, and packets sent. I'm giving a name to each one of them, and those names I'm exposing them globally, let's say at the VNF, by giving them an ID, a name, the BDU that is that is bringing that is monitoring these metrics, and the metric name. So this specification here lets us reuse these monitoring params for taking actions like scaling descriptor. So for example, CPU util that I'm putting here is being, VNF CPU util, I'm putting here the name of the monitoring param at the VNF level, is being used as the scaling descriptor for scaling in or out depending on the value of the CPU. And it will scale in or out the only VM we have, which is called Hackfest Basic Metrics VM, the ID of the VDU. And it will instantiate just 1 at most, but I could put 10 or 100 or whatever you want there. Okay, so if you run the example, you will find most of you already did. Great. I will look for mine. And you will see that you have CPU utilization, memory utilization, network traffic by default. There are also some examples there in that dashboard for metrics, for VNF indicators through UU metrics, if you want to enable that in the VNF. But at the end, it's just a matter of editing the file. I mean, no, what is collected in the Grafana configuration. Well, what you can do as well is go into your VNF. So if I follow this slide here on auto-scaling, just type in OSM VNF list and see the IP address, the management IP address of your VNF, and you can log in with the OSM for view password, and finally you can run this command here for artificially overloading the CPU, so 4 or 5 times, and then you will see that the CPU goes up, and eventually, so granularity is still 5 minutes. We can lower that in the Vim down to 30 seconds, I guess, but we intentionally don't do so because the Vim will become overloaded. So you have to wait 5 minutes, and then after the 5 minutes have passed, MON will put an alarm on the bus. The policy manager would read that alarm and will send an instruction to scale up the VDU, and LCM will take that message from the bus and proceed with instantiation. And whenever you kill that process here, that is yes process, then CPU will come down again, and you will see that the VM is scaling in. Okay, so there you go. Mine is already climbing up to 25% CPU utilization. And then in the next cycle, probably it will scale, because Gnocchi is providing an average from the hypervisor, or it's not immediate, but you will see that whenever it reaches, I guess it's 60, what we configured here, so the scale out threshold is 60, you will see that the VM scales, and that would mean adding a VDU with the same characteristics of the previous VDU. Obviously, it gets a new IP address, but is instantiated next to the one that appears here. It is, for nowadays, is responsibility of the VNF to do something about balancing the load between VNFs. So what we have seen is VNFs that are configured with a routing protocol for providing load balancing through routing protocols, or load balancers that are already instantiated, I mean physical or virtually, and you just need to add the new instance there. What we're working on is on post-scaling primitives or actions, so that after scaling has occurred, we can configure something. Something would be, for example, a load balancer or a peer to make the VNF aware of the new instance and do something with it. Well, this is still moving, and you will definitely see somebody already saw this scaling of OSM Hackfest 8, for example. So we can go there and see. It's already at 70% OSM Hackfest 8, and if I access, just for you to see what Lorenzo already finished, we'll see the 2 instances there already scaled. And the system, if you keep the load up, the system will still throw will try to scale up. I mean, policy manager will try, but LCM will know that you can't, because the descriptor is set to 1 scaled instance, so it won't scale more than that. And then what you can do is just stop the load, and you will see the scaling happening.